Hello viewers, welcome back to our channel Career Prep. Today we will learn divisibility rules for numbers from 2 to 20. Having a knowledge about divisibility rules will help you in solving many problems in quantitative aptitude faster. This is especially useful in simplification problems. Questions based directly on divisibility rules are also asked in many competitive exams. Before we begin, please subscribe to our channel. Also press the bell icon to get notifications as soon as we post a new video. So let's start. Divisibility rules make the division procedure easier and quicker. These rules helps you to check whether a number is divisible by another number just by examining its digits. There is no need to perform the actual method of division. If a number is completely divisible by another number, then the quotient will be a whole number and the remainder will be 0. Mastering these rules is very important to solve questions at a faster pace. So, let's learn the division rules for numbers from 2 to 20 with solved examples. The divisibility rule of 1 is not required since every number is divisible by 1. Divisibility rule of 2. If you have to know whether the given number is divisible by 2 or not, check the last digit of the given number. If the last digit of the given number is an even number, that is 2, 4, 6, 8 or 0, then the given number is always completely divisible by 2. For example, take the number 74. The last digit is 4. 4 is divisible by 2. So 74 is divisible by 2. The number 280 has 0 as the last digit. So number 280 is divisible by 2. 1346 has 6 as the last digit. 6 is divisible by 2. So 1346 is also divisible by 2. Divisibility rule of 3. If the sum of the digits of the given number is divisible by 3, then the given number is always completely divisible by 3. This means to find out if a given number is divisible by 3 or not, you have to add the digits of the given number. If the answer is divisible by 3, then the given number is also divisible by 3. For example, take the number 345. The sum of the digits of the number 345 is 3 plus 4 plus 5, which is 12. 12 is divisible by 3. So 345 is also divisible by 3. Divisibility rule of 4. If the number formed by the last two digits of the given number is divisible by 4, or if the last two digits are 0, 0, then the given number is always completely divisible by 4. This means that if you have to find out whether a number is divisible by 4 or not, you have to consider the last two digits of the given number. If the last two digits of the given number form a number which is divisible by 4, or if the last two digits of the given number are 0, 0, then the given number is divisible by 4. Let's understand this with an example. Consider the number 40832. This number is divisible by 4 because the last two digits are 3 and 2, and the number formed by the last two digits 32 is divisible by 4. Consider the number 7000. Here the last two digits is 00. So this number is also divisible by 4. Divisibility rule of 6. If the given number is divisible by both 2 and 3, then the given number is always completely divisible by 6. So a number is divisible by 6 only if it is divisible by both 2 and 3. Consider the number 1458. To check whether this number is divisible by 6, you have to find out whether 1458 is divisible by 2 and 3. Only if this number is divisible by both 2 and 3, then it is divisible by 6. So to check whether this number is divisible by 2, consider the last digit. Last digit is 8. 8 is an even number and it is divisible by 2. So this number is also divisible by 2. To check whether 1458 is divisible by 3, you have to add all the digits of the number. So sum of digits is 1 plus 4 plus 5 plus 8. The answer is 18. 18 is divisible by 3. So 1458 is also divisible by 3. So now we have found out that 1458 is divisible by 2 and also by 3. So the given number 1458 is divisible by 6 also. Divisibility rule of 7. If subtracting twice the last digit of the given number from the remaining digits gives a multiple of 7, then the given number is always completely divisible by 7. This means to check if a given number is divisible by 7, you have to multiply the last digit of the given number by 2, and the answer you get you have to subtract from the remaining digits, and the final answer, if it is divisible by 7, then the given number is also divisible by 7. Let us understand this with an example. Consider the number 483. Here 3 is the last digit. Multiply 3 with 2. So twice the last digit is 6. 2 times 3 is 6. Now the remaining digits are 48. Subtract 6 from 48. So 48 minus 6 is 42. 42 is divisible by 7. So the number 483 is divisible by 7. Divisibility rule of 8. If the number formed by the last three digits of the given number is divisible by 8, or if the last three digits are 000, then the given number is always completely divisible by 8. This means that if you have to find out whether a given number is divisible by 8 or not, you have to consider the last three digits of the given number. If the last three digits of the given number form a number which is divisible by 8, or if the last three digits are 000, then the given number is divisible by 8. Let's understand this with examples. Consider the number 34152. Here the last three digits 152 form a number 152, which is divisible by 8. So this number is divisible by 8. Consider the number 528000. This number is divisible by 8 since the last three digits are 000. Divisibility rule of 9. If the sum of the digits of the given number is divisible by 9, then the given number is always completely divisible by 9. This means if you have to check whether a given number is divisible by 9, then add all the digits of the given number. If the answer you get is divisible by 9, then the given number is also divisible by 9. Let's understand this with an example. Consider the number 2880. This number is divisible by 9 because the sum of its digits 2 plus 8 plus 8 plus 0 is 18. 18 is divisible by 9. So the number 2880 is also divisible by 9. Divisibility rule of 10. If the last digit of the number is 0, then the given number is always completely divisible by 10. Consider the number 30. The last digit is 0, so 30 is divisible by 10. Consider the number 430. The last digit is 0, so 430 is divisible by 10. Consider the number 8000. The last digit is 0. So 8000 is divisible by 10. Divisibility rule of 11. If the difference of the sum of its digits in odd places and the sum of its digits in even places is either 0 or a multiple of 11, then the given number is always completely divisible by 11. This means if you have to check whether a given number is divisible by 11, then first you have to find the sum of the digits in odd places. Then find the sum of its digits in even places. Then find the difference between the two. If the answer you get is 0, then the number is divisible by 11. If you get the answer which is divisible by 11, then the given number is also divisible by 11. Let us understand this with an example. Consider the number 918082. To check whether this number is divisible by 11 or not, first find the sum of its digits in odd places. That is 9 plus 8 plus 8. You will get the answer as 25. Then find the sum of its digits in even places. That is 1 plus 0 plus 2. The answer is 3. Now find the difference between these two. That is, subtract 3 from 25. 25 minus 3 is equal to 22. 22 is divisible by 11. So the number 918082 is also divisible by 11. Understand that odd places means the first place and leave one, and then the third place, then the fifth place, then the seventh place, and so on. Even places means the second place, fourth place, sixth place, eighth place, and so on. Divisibility rule of 12. If the number is divisible by both 3 and 4, then the number is always completely divisible by 12. So To find out whether a number is divisible by 12 or not, you have to check whether the number is divisible by 3 and 4. If the number is divisible by both 3 and 4, then the number is also divisible by 12. Let's understand this with an example. Consider the number 5856. To check whether this number is divisible by 12, you have to find out whether this number is divisible by both 3 and 4. To check whether this number is divisible by 3, first add all the digits in the number. So, sum of the digits is 5 plus 8 plus 5 plus 6, which is 24, and 24 is divisible by 3. So the number 5856 is also divisible by 3. Now let's check if this number is divisible by 4. To find whether it is divisible by 4, consider the last two digits. The last two digits are 56. 56 is divisible by 4. So 5856 is divisible by 4. So the given number 5856 is divisible both by 3 and 4. Hence, it is also divisible by 12. Divisibility rule of 13. Add 4 times the last digit of the number to the remaining number and repeat the process until you get a 2-digit number. Now check if the 2-digit number is divisible by 13 or not. If it is divisible by 13, then the given number is also divisible by 13. This means if you have to find whether a given number is divisible by 13, you have to consider the last digit of the number. Multiply the last digit of the number with 4, and the answer you obtain you have to add to the remaining number. You have to repeat the process until you get a 2-digit number. If this 2-digit number is divisible by 13, then the given number is also divisible by 13. Let's understand this with an example. Consider the number 2795. Here 5 is the last digit. The remaining digits are 279. So multiply the last digit with 4. 5 multiplied with 4 is 20. Add 20 to the remaining digits. So 279 plus 20 is 299. Now repeat the process. Here 9 is the last digit and 29 is the remaining digits. Multiply 9 with 4. 9 multiplied with 4 is 36. Add 36 to the remaining digits. So 29 plus 36 is 65. Number 65 is divisible by 13. Hence, the given number 2795 is also divisible by 13. Divisibility rule of 14. If the number is divisible by both 2 and 7, then the number is always completely divisible by 14. This means to check if a number is divisible by 14, then that number has to be divisible by both 2 and 7. Only if the number is divisible by both 2 and 7, then the number is also divisible by 14. Let's understand this with an example. Consider the number 1764. 1764 will be divisible by 14 only if this number is divisible by both 2 and 7. So to check whether 1764 is divisible by 2 or not, consider the last digit. The last digit is an even number 4. 4 is divisible by 2. So 1764 is also divisible by 2. Now you have to check whether 1764 is divisible by 7. To do that, Consider the last digit. The last digit is 4. Multiply 4 with 2. You get the answer as 8. 4 multiplied by 2 is 8. Subtract this number from the remaining numbers. The remaining number is 176. So 176 minus 8 is 168. 168 is divisible by 7. So the given number 1764 is divisible by both 2 and 7. So it is also divisible by 14. Divisibility rule of 15. If the number is divisible by both 3 and 5, then the number is always completely divisible by 15. This means if you have to check whether a number is divisible by 15, then you have to check if the number is divisible by 3 and 5. Only if the number is divisible by both 3 and 5, then the number is also divisible by 15. Let's understand this with an example. Consider the number 1470. To know whether this number is divisible by 15, this number has to be divisible by both 3 and 5. So let's check first if this number 1470 is divisible by 3. To do that, you have to add all the digits in the number. So sum of the digits is 1 plus 4 plus 7 plus 0, which is 12. 12 is divisible by 3. So the number 1470 is also divisible by 3. Now to check whether this number is divisible by 5, look at the last digit. The last digit is 0. So the number 1470 is divisible by 5. Thus, the given number 1470 is divisible by 3 and 5. So it is also divisible by 15. Divisibility rule of 16. To check whether a given number is divisible by 16, the thousands digit is considered. Here there are two possibilities. The thousands digit can be an even number or an odd number. If the thousands digit is an even number, then the number formed by the last three digits must be divisible by 16. However, if the thousands digit is odd, then the number formed by the last three digits plus 8 must be divisible by 16. Let's understand this with an example. Consider the number 254176. Here the units digit is 6, tens digit is 7, hundreds digit is 1 and the thousands digit is 4. So the thousands digit is 4, which is an even number. Here the last three digits of the given number is 176, which is divisible by 16. So the number 254176 is also divisible by 16. Hope you understood that. The thousands digit is 4, which is an even number. So you have to consider the last three digits of the number. Here it is 176. 176 is divisible by 16. So the given number 254176 is also divisible by 16. However, if the thousands digit is odd, then the number formed by the last three digits plus 8 must be divisible by 16. So consider the example 157648. Here units digit is 8, tens digit is 4, hundreds digit is 6 and the thousands digit is 7. So here the thousands digit is 7, which is an odd number. So the last three digits of the given number is 648. 648 plus 8 is 656. 656 is completely divisible by 16. So the given number 157648 is also divisible by 16. Hope you got that. In the number 157648, 7 is the thousands digit. 7 is an odd number. So you have to when you consider the last three digits of the number 648, you have to add 8 to 648. The answer is 656. So 656 is divisible by 16 and hence the number 157648 is also divisible by 16. Divisibility rule of 17. Subtract 5 times the last digit of the given number from the remaining digits. If the result is divisible by 17, then the given number is also divisible by 17. This means to check if a given number is divisible by 17, consider the last digit of the given number. Multiply the last digit with 5 and the answer you get you have to subtract from the remaining digits. If the result is divisible by 17, then the given number is also divisible by 17. Let's understand this with an example. Consider the number 4675. The number 4675 has 5 as the last digit. Multiply 5 with 5. 5 times the last digit is 25. 5 multiplied by 5 is 25. The remaining digits are 467. So 467 minus 25 is 442. 442 is divisible by 17. So the given number 4675 is also divisible by 17. Divisibility rule of 18. If the given number is divisible by both 2 and 9, then the given number is always completely divisible by 18. So to check whether a given number is divisible by 18, you have to find out whether that number is divisible by both 2 and 9. Only if the given number is divisible by both 2 and 9, then it is also divisible by 18. Let's understand this with an example. Consider the number 2322. This number will be divisible by 18 only if it is divisible by both 2 and 9. So let's find out first if it's divisible by 2. The number 2322 has 2 as the last digit. So it's divisible by 2. To find out whether this number 2322 is divisible by 9, you have to add the digits of the number. So sum of the digits is 2 plus 3 plus 2 plus 2, which is 9. 9 is divisible by 9. So 2322 is divisible by both 2 and 9. Since the number 2322 is divisible by both 2 and 9, it's also divisible by 18. Divisibility rule of 19. Add twice the last digit of the number to the remaining digits and repeat the process until you get a two-digit number. Now check if that two-digit number is divisible by 19 or not. If it is divisible, then the given number is divisible by 19. So to check whether a given number is divisible by 19, you have to consider the last digit of the number. Multiply the last digit of the number with 2 and then add the answer to the remaining digits. You have to repeat this process until you get a 2-digit number. Now check whether this 2-digit number is divisible by 19. If it's divisible by 19, then the given number is also divisible by 19. Let's understand this better with an example. Consider the number 6935. Here, the last digit is 5. The remaining digits are 693. So, multiply the last digit with 2. 5 into 2. 5 multiplied by 2 will give an answer 10. 5 multiplied by 2 is 10. So, add 10 to the remaining digits. So, 693 plus 10 is 703. Now repeat the process. Here 3 is the last digit and 70 is the remaining digits. Multiply 3 with 2. 3 multiplied by 2 is 6. So add this 6 to the remaining digits, that is 70. So 70 plus 6 is 76. 76 is divisible by 19. So the given number 6935 is also divisible by 19. Divisibility rule of 20. If the number formed by the last two digits of the given number is divisible by 20, then the given number is also divisible by 20. This means to check whether a given number is divisible by 20, consider the last two digits of the given number. If the last two digits of the given number is divisible by 20, then the given number is also divisible by 20. Let's understand this with an example. Consider the number 1580. The last two digits of the given number is 80. 80 is divisible by 20. Hence, the given number 1580 is also divisible by 20. So now let's recap the divisibility rules we have learned till now. I have grouped together the divisibility rules for 2, 5, 10 and 20 so that because they have a similarity. So this similarity will help you to remember the divisibility rules for 2, 5, 10 and 20 better. If the last digit of a given number is even, that is 0, 2, 4, 6 or 8, then the number is divisible by 2. If the last digit is 0 or 5, then the given number is divisible by 5. If the last digit is 0, then the given number is divisible by 10. If the number formed by the last two digits of the given number is divisible by 20, then the given number is divisible by 20. The divisibility rule for 3 and 9 have a similarity, so they have been grouped together here. To find whether a number is divisible by 3, you have to add all the digits. If the result is divisible by 3, then the given number is divisible by 3. Similarly, when you add all the digits of the given number, if the result is divisible by 9, then the given number is also divisible by 9. The divisibility rule for 4 and 8 have a similarity. So these two are grouped together. Let's first consider the divisibility rule for 4. A number is divisible by 4 if the last two digits of the given number form a number that is divisible by 4, or if the last two digits are 0, 0. For a number to be divisible by 8, the last three digits of the given number should form a number that is divisible by 8, or the last three digits should be 000. The divisibility rule for 6, 12, 14, 15 and 18 have a similarity. So these are grouped together. For a number to be divisible by 6, it should be divisible by both 2 and 3. For a number to be divisible by 12, it has to be divisible by both 3 and 4. For a number to be divisible by 14, it has to be divisible by both 2 and 7. For a number to be divisible by 15, it has to be divisible by both 3 and 5. For a number to be divisible by 18, it should be divisible by both 2 and 9. Now, factors for 6, 12, 14, 15 and 18 are not selected at random. They are selected because they are coprimes. What are coprimes? Coprimes are numbers that have their HCF as 1. The coprime numbers can be prime numbers or composite numbers. Consider the number 18. 18 can be written as 1 multiplied by 18 or 2 multiplied by 9 or 3 multiplied by 6. Here only 2 and 9 are selected. Here 2 multiplied by 9 is selected because 2 and 9 are coprimes. Although 1 and 18 are also coprimes, they are not considered because all numbers are divisible by 1. And here, since you are supposed to find divisibility by 18, considering 18 does not make any sense. So, the numbers 2 and 9, which are coprimes, are selected for 18. Similarly, when you consider the number 15, the factors for 15 are 1 multiplied by 15 or 3 multiplied by 5. But we will not consider 1 multiplied by 15. 3 multiplied by 5. 3 and 5 are coprimes. So, the numbers 3 and 5 are considered for divisibility of 15. Similar is the case for 6, 12 and 14. For 14, 2 and 7 are coprimes. So they are considered for divisibility of 14. 3 and 4 are coprimes. So they are considered for divisibility of 12. Similarly, 2 and 3 are coprimes. So they are considered for divisibility for 6. Hope you have understood this concept. The divisibility rule for 7 and 17 have a similarity, so they have been grouped together. To find out whether a number is divisible by 7, subtract 2 times the last digit from the remaining digits. If the result you get is divisible by 7, then the number is divisible by 7. Similarly, subtract 5 times the last digit from the remaining digits. If the result you obtain is divisible by 17, then the number is divisible by 17. Observe the difference here. For divisibility by 7, you have to multiply the last digit with 2. For divisibility by 17, you have to multiply the last digit with 5. The divisibility rule for 13 and 19 have a similarity, so they are grouped together. To find whether a number is divisible by 13, add 4 times the last digit to the remaining digits. If the result obtained is divisible by 13, then the given number is also divisible by 13. To check whether a number is divisible by 19, you have to add twice the last digit to the remaining digits. If the result obtained is divisible by 19, then the given number is also divisible by 19. Observe the difference here. For a number to be divisible by 13, you have to multiply the last digit of the given number with 4. For a number to be divisible by 19, you have to multiply the last digit of the given number with 2. The divisibility rule for 11 and 16 are special cases. So to find if a given number is divisible by 11, first find the difference of the sum of its digits in odd places and the sum of its digits in the even places. If the answer obtained is 0, then the given number is divisible by 11. Or if the answer obtained is divisible by 11, then the given number is also divisible by 11. For a number to be divisible by 16, you have to consider the thousands digit. If the thousands digit is even, then the number formed by the last 3 digits of the given number must be divisible by 16. However, if the thousands digit is odd, then the number formed by the last 3 digits plus 8 must be divisible by 16. Then the given number will be divisible by 16. Viewers, please go through this video till you are perfect with the concept. For solved questions on divisibility rules, please watch my next video. If you have liked this video, please like, subscribe and share this video. Thank you.